So guys, welcome you all to lecture 10, that is probably the last lecture of module 1. So here in this lecture we'll be discussing about the introduction to the amplifiers. So let us begin the lecture. Here we go. Guys, moving on to introduction to amplifiers. So the first topic to be covered is what is an amplifier? So an amplifier can be defined as it's a device which is used to increase the signal level. It is used to get a larger signal output from a small signal input. Let us assume we have a very small amplitude signal. In order to increase to a very high amplitude signal, we need to transfer this through a amplifier. So the amplifier has a property to increase its magnitude or the amplitude, keeping the frequency constant. So to make the transistor work as an amplifier, it is to be biased to operate in active region. So a transistor need to be biased, that is, the voltage source should be driven to the transistor. It means the base emitter junction is forward bias and the base collector junction should be reverse bias. In the absence of input signal, only DC voltage is present in the circuit. Let us considering that it is known as the zero signal, which we have discussed in the previous lecture. So here what happens, the question point arises where the collector emitter voltage VCE, DC collector current IC and base current IB is the question operating point for the amplifier. Due to this, the base current varies sinusoidally by producing, or it could also produce or not produce a phase difference. Now moving on to the three kinds of the configuration of the amplifier, that is the common emitter amplifier, the common collector amplifier and the common base amplifier. So the common emitter amplifier is the amplifier where the emitter is connected, that is common to the input as well as to the output, whereas the common collector amplifier, the collector is common for the input as well as the output, whereas the same with the base one. So these three configurations let us discuss in details. Moving on to common base amplifier. So in common base amplifier, the base is connected to the input as well as the output. So here what happens, the source is coupled to emitter through C1. Through C1, the emitter is coupled with the source. The source voltage and the emitter voltage both are coupled with each other. Here, and as well as in the right hand side you could see RL is coupled to C1 and C2. Here the RL, the load resistance RL is coupled with the capacitor C2 through the collector point, and here the capacitor C1 is coupled with the source through the emitter point. So the positive input increases with increase in the voltage across the emitter. So when in positive half cycle, the input increases when the voltage across the emitter voltage increases. Then the base voltage remains constant. Here the voltage VBE remains constant. In forward bias, the emitter base junction increases. The emitter and the base junction here, when the forward bias increases, IB and IC reduces through the current IB and the current IC reduces. Therefore, as we know, V naught equals to VCC minus IC RC from the circuit. So when IC increases, when the IC decreases, the V naught increases. So we could say When a low amplitude signal is given, it converts to a very high output signal through RL. So it amplifies the low amplitude signal to a high amplitude signal through V0. So guys, now in common emitter amplifier, you could see this is the circuit. The emitter is connected to the input as well as to the output. So here what happens, R1, R2 and RE, these form the R1, R2 and the RE, these form the voltage divider bias to improve the operating point of the circuit, where the capacitor C1 couples the signal to the base of the transistor. This couples the signal to the base of the transistor, and by doing this it blocks the DC and allows only the AC signal to the transistor, where the capacitance CE is connected parallel to the RE, which provides a low reactance path for the current to flow, where the capacitance C2, it couples to the output RL and is also helps in connecting this to the further stage. Suppose we have a 2-stage or a 3-stage amplifier, this C2 will be connected to the input of the next stage of the amplifier. This in turn increases the amplifier's gain if we do it in a cascaded manner. Now these are the components which are connected to the or used in this common emitter amplifier. There are few more points regarding this common emitter amplifier. Those are the the phase relationship. The phase relationship between the input and output voltages can be determined by considering the effect of positive and negative half cycles separately, where the collector current is beta times the base current, where it follows the equation, that is Vc equals to Vcc minus IcRc. Here also in the same manner, the increase in IC results in the drop in collector voltage Vc, as Vcc is constant. Therefore Vi, the current Vi increases in positive direction. The current Vi increases in a positive direction, and this direction goes separately, that is the V0 gives in negative direction, and negative half cycle of the output can be obtained for the positive half cycle of the input. So this also provides a 180-degree phase shift, that is the negative half cycle of the input provides a positive half cycle in the output. Therefore in negative half cycle of input, AC and DC voltage will oppose each other. This will reduce the base current. Accordingly, collector current and drop across RC will reduce, and it increases the output voltage. Therefore, by reducing the base current, the output voltage V0 will increase, which satisfies the property of an amplifier or a common emitter amplifier, that is a low amplitude signal gets converted to a high amplitude signal, that too with a voltage, very high voltage gain as well as a phase shift of 180 degrees. So guys, next moving on to the common collector amplifier. So this circuit represents the common collector amplifier. Here the collector is being connected to both the input as well as the output. So here what happens, the resistances R1, R2 and R3, that is the resistances R1, R2 and RE, these provide the DC biasing for the circuit, and here RL is capacitor coupled, and here VB, the voltage VB is the voltage across the base, increases or decreases according to the positivity or negativity of the signal. That is, if you have a positive signal, the VB increases, and if you have a negative half cycle, in positive half cycle of the input, the VB increases, and for the negative half cycle of the input, the VB decreases. But if the VB is kept constant following the equation that is from the circuit, that is VE equals to VB minus VBE. Following this equation, we could say that when the increase in the VB is constant, the output voltage will increase for the, so the variation in VB appears at emitter and emitter voltage VE will vary same as base voltage VB. In common collector circuit, emitter terminal follows the signal voltage applied to the base. So the collector, in this situation, this follows the emitter this circuit can be said as the emitter follower circuit. So in this circuit, the input signal of very low amplitude gets to a very high amplitude output signal following the property of an amplifier. Discussing the common emitter, common collector and common base amplifier, let us compare the properties of these three configurations. So moving on to the first property, that is voltage gain. So voltage gain is high both in the common emitter as well as the common base configuration, whereas it is less than 1 in case of common collector. In the other hand, the current gain is less than 1 in case of common base, whereas high both in the common emitter as well as the common collector. Now, we could see that the variation of the voltage and current provides a very drastical change in the common base and common collector format, that is very high to less than 1. This occurs because as V equals to IR following the Ohm's law, the voltage and the current are directly proportional to each other, so that in the variation of the configuration there is a huge resistance, the equivalent resistance change in the circuit, which produces this alter. Now moving on to the power gain, it is moderate in case of common base as well as the common collector, whereas it is high in case of common emitter. As in common emitter, the voltage gain and current gain both are high, and following the power formula, that is power which is equals to voltage into current. Therefore, as the voltage is high and the current is high, the power also has to be high. Now, phase inversion. We have also seen that in common base and common collector there is no phase inversion, but a 180-degree phase shift is observed in case of common emitter. Now moving on to the input impedance, it is low in case of the common base, that is up to 50 ohms. It is moderate up to 1 kilo ohm in case of common emitter, whereas it is very high, that is up to 300 kilo ohm in case of common collector. Whereas talking about the output impedance, it's very high, the highest, that is up to 1 mega ohm in case of common base. In common emitter, it's moderate up to 50 kilo ohms, and it is low, that is 300 ohm in case of the common collector. Guys, today in this lecture we discussed all the introduction regarding to the amplifier, and we discussed the three configurations, that is the common emitter, common base and common collector configurations in details. So this is the last lecture of module 1. In the next class we'll be discussing about the problems regarding the entire module 1. So if you find this video informative, please hit the like button and comment below if you have any doubt regarding any topic in the entire first module. We'll also be discussing the questions in the next class, and subscribe the channel to stay connected with us. Thank you.